Hi, welcome to the Olympiad Geometry Club. Let's continue our study. Today we are going to talk about 1974 IMO longlists problem. So before we start, if you think this video is helpful, please click the like button, comment, share, or subscribe to the channel. Here is the problem. Through the circumcenter O of an arbitrary acute angle triangle, chords A1, A2, B1, B2, C1, C2 are drawn parallel to the sides BC, CA, AB of the triangle respectively. If R is the radius of the circumcircle, prove that A10 times OA2 plus B10 times OB2 plus C10 times OC2 equals 2 R squared. So we have this circumcircle and we have the triangle ABC, and we know that we have the three parallel lines that are passing through the center O. Right? And obviously we need to choose A1 to be here, A2 to be here. Right? Otherwise OA1 times OA2 is already R squared. And B1, B2, right? C1, C2. Now we want to prove that OA1 times OA2 plus OB1 times OB2 plus OC1 times OC2 equals 2 R squared. So basically we want to prove A10 times OA2 divided by R squared plus B10 times OB2 divided by R squared plus C10 times OC2 divided by R squared equals 2Y. Right, let's consider about this term. A10 times OA2 divided by R squared, we can make it to be A10 divided by R times OA2 divided by R. Right. So we know that A10 divided by R equals 2. A10 to R equals 2 sine angle ABO2 sine angle BA10, which equals 2. So what is angle ABO? Angle ABO equals to angle BAO, which is 180 degree minus angle BOA, and then divided by 2, right? And we know angle BOA is twice of angle C, which means angle angle ABO is 90 degree minus angle C. So sine angle ABO is cosine angle C divided by sine angle BA10. Angle BA10 equals to 180 degree minus angle A1A2, and angle A1A2 equals to angle ABC. So sine angle BA10 equals to sine 180 minus angle B, right? So it is sine angle B, which means we get similarly OA2 to R would be, look at here, OA1 to R is eventually cosine C to sine B, right? And OA2 would be this angle, which is cosine B to and to are to this sine of this angle, which is sine of this angle, which is sine C. Now we know that A10 to R times OA2 to R is cotanent 1 over cotanent B. No, sorry. Cotanent B times cotanent C. Okay, now we can get that A10 times OA2 to R squared plus B10 times OB2 to R squared plus C10 times OC2 to R squared equals to cotanent B times cotanent C plus cotanent C times cotanent A plus cotanent A times cotanent B. Right, we have this one. And we already know that in a triangle, in any triangle, tangent A plus tangent B plus tangent C equals to tangent A times tangent B times tangent C. I proved this before, right? So I'll just use this here. And based on this, we know that 1 over cotangent A plus 1 over cotangent B plus 1 over cotangent C equals to 1 over cotangent A times cotangent B times cotangent C. Okay, from this term, we know this is true, right? We know we can multiply cotangent A, cotangent B, cotangent C on the both sides. Then we got cotangent A, cotangent B plus cotangent B, cotangent C plus cotangent C, cotangent A equals to 1, right? So we just prove this one equals to 1, which means A10 times OA2 plus B10 times OB2 plus C10 times OC2 equals to R squared. Okay, so it's a very simple problem. As you can see, in the early days, IMO is really easy. I think maybe the most difficult part would be here. Like at that time, maybe people this is not a well-known formula, so some people need to prove that. Okay. But this problem for today, students would be very easy. Okay, I hope you like this video. See you in next one. Thank you.